All right, today we are starting section 1.2. We are going to be solving multi-step equations. So the last couple days of notes, we've just been doing one step. These ones will require more than one step. Let's get to our warm-ups. Give you a moment to do those. These are all one-step problems. We will talk about them in just a minute. All right, let's go through these. On the first one, how are we going to get W by itself? Dominic?
Divide 4 by each side, which gives us minus 12.
Good. Divide both sides by a 4. That's how we undo multiplication. We get W equals negative 12 as our answer. On number 2, what should I be doing? We went over these types of problems yesterday. Switch it, good. And do what operation on both sides? Multiplication. We call that multiplying by the reciprocal. So we're multiplying both sides by 4 over 1, or just 4. So on the left side, those fractions cancel each other out. That leaves us with the x. 48 times 4. Brian?
I was going to ask you a question.
Let's get through this and then I'll take your question. 48 times 4? 192. All right. Number 3, what did we do to get s alone?
Times -2.
Multiply both sides by a negative 2. What do we get for s when we do that? Loud and proud. 10. Positive 10. All right, number 4. We haven't looked at this situation for a few days. Does anyone think they know what W equals? Not 1, but a couple people said it. Dominic, what do you think?
Is it 10?
It is 10. We want positive W. So if we know the opposite of W is negative 10, if we changed up it to W, we also change the sign on the 10 to become positive. Some people, I'll write this off to the side, think about it as multiplying by a negative 1. So to undo that, you divide by a negative 1. Either way you think about it is fine. If you want to think about it as dividing off a negative 1, that is also fine. Questions, concerns? Okay, we will continue. When solving a multi-step equation, simplify each side of the equation if necessary. Then use inverse operations to isolate the variable. So remember what I've said about listening, reading, then writing? So if I were to put solving multi-step equations, 1, what's the first thing it says to do? First sentence. Simplify each side. Simplify each side, which really means that we're doing things like combining like terms. Then, second, what does it want me to do after that? Use inverse operations. Get the variable alone. So however you want to word it, I would just put get variable alone. Hopefully we know by now that we use inverse operations to do that. So if these were my notes, I would just write the title and my 1-2. You don't necessarily have to write every slide word for word. Here we've got 2 tips for solving an equation with the variable on one side. So it's really nothing new. Okay, this is the same as the last slide, worded a little different. So I would not be worried about writing this slide down if you got the last one. Simplify each side of the equation as necessary. If you want to make a note by that saying that what you should do is combine like terms or distribute, things like that, that's what we mean by simplify. If anything like that is necessary, that's when you should do it. Okay, then this just goes into depth about how you would get the variable alone. The important part here is that when we do our order of operations, we do it in the opposite order. So we're going kind of backwards from how we've done our order of operations before. When you're solving equations, the order of operations is opposite order. Meaning that we undo addition and subtraction first, then we work on undoing multiplication and division. Okay, so this slide isn't really anything new, it's just going in a little more detail. You want to add a couple notes by what you already wrote. All right, we're jumping straight into our examples now. Make sure you copy down the original problem. Our directions are to solve, which means we are getting the variable by itself. And we are going to show all of our work for doing that. So we are doing our order of operations in the opposite order. So that means if it helps you to write your opposite order up there, you can do that. Put it in reverse. So we need to undo subtraction and addition first. Okay, really before we do that, we should make sure that we don't have anything to simplify. I jumped ahead there. Can we simplify 2x minus 7? No. Why can those not combine? There's no x by the 7. Those are not like terms. Can we simplify 4? No, there's nothing else by it. Okay, so there's nothing to simplify. Now we do our reverse order of operations. So we are trying to undo subtraction first. How do we undo that subtraction? Using addition. But if we do it to one side, we have to do it to the other. What do I still have on the left side of my equation? 2x. A 2x. So I write that down again. Equals 4 plus 7
11.
Is 11. We're still trying to get x alone, so if you want to rebox it, you can. All right, now what do we still need to do to get x alone? Divide both sides by 2. And what do we get for x? 5.5 would be acceptable. If you left it as a fraction of 11 over 2, technically that's fine. If you wrote it as 5 1/2, technically that's fine. All of those represent the same number. Okay. Number 2, do we have any like terms to combine?
No.
Anything to distribute? No. If there's nothing to simplify, we're just going to jump into our reverse order of operations. So we're getting n alone. I agree with Jasha, we should add the 9. So what are we left with on the left side?
5n.
Still have a 5n. Equals 80. We are still working on getting that n alone. So what do I need to do next? Divide by 5. We get n equals
16.
all right, on number 3, is there anything for us to simplify?
I think
What?
I don't supposed to put like 1 over there, under 9 to put them go together, or
We don't need to because we can't combine them anyway.
Oh, that one.
So they're not like terms. So we don't need to do that. So there isn't anything here to simplify. or distribute, nothing to combine, nothing going on. So we're ready to start using our inverse operations. Okay, so we work our backwards. We get rid of subtraction first by adding 9. What does that leave me with on the left? 1/5 x equals 12. Okay, we're still getting x alone. So what do we need to do now? Okay, we multiply both sides by the reciprocal. Good. So we flip the fraction over. If you want to put the 12 over 1, you can. Okay, that's fine. On the left side, what happens to our fractions? They cancel out. That leaves us with x equals.
But you cancel the 1 out on
So we could write it as 60 over 1, but that's the same as just 60. So I'm fine with either one. You do not have to write the ones. When we multiply fractions, we multiply the tops together, and then we multiply the bottoms together. Questions, concerns? Okay, either one of those is fine for your answer. On number 4, we're switching it up just a little bit.
-3.
We have to undo addition. To undo addition, we use subtraction. What does that leave me with on the left? 1/2 x equals. Careful. 6. Okay, still trying to get x alone. What do I do next? Multiply by the reciprocal. What's the reciprocal? 2 over 1. Or just 2. You can put it over 1 if you want. Fractions cancel out, leaving me with x equals 12. Again, you can put it over the 1, but it's not necessary. All right, these types of problems tend to get a little tricky for some people. So I would pay special attention to them. All right, fraction bars serve 2 purposes. What's one purpose that fraction bars serve us in math? Division. Does anybody remember the other one we talked about? Hunter? Nope. It was in one of our review days, one of the first review days. It's a grouping symbol. We talked about how fraction bars work as grouping symbols. So it groups the top separate from the bottom. So if we're thinking about our reverse order of operations, bless you. If we think about our reverse order of operations, where do grouping symbols land? Or parentheses? Do they come first? If we're going backwards, where do they come? Parentheses comes last. Our grouping symbols comes last. So if we have a big old fraction bar, we need to get rid of anything below it before we deal with what's on top of it. Okay? Moral of the story is you don't want a fraction bar there anymore. So try to get rid of it. We're going to get rid of it, as some people have already said, by multiplying both sides by 2. Now here is a common mistake that I see people make. I want you to look at it and tell me why it's wrong.
Because they cancel out.
Very good, Jaysha. The 2's are supposed to cancel out here. We're not distributing the 2 or giving the 2 to that numerator. Don't do that. We don't want it. The 2's cancel each other out. That was the whole point of having the 2 there, was to cancel it with the bottom. So what do we have left over there?
K minus K.
K minus 4. We still need another step to solve.
Add 4.
Add the 4 on both sides. What do we get for K? 30.
30.
What's the first thing we did?
Times 9.
Good. I would agree. We multiply both sides by 9. What happens to the 9s on the left?
Cancel out.
What does that leave us with?
This 23.
Good. 2 times 9 is? Last step.
Add 5.
Do it on both sides.
23.
W equals 23. What's different about these two from the ones we've done so far?
They have like terms.
They have like terms, which means we have to simplify before we do anything else. How can we simplify number 7, Hunter?
You combine like terms together.
And what do we get?
5x.
Okay, so we have 40 equals 5x.
Don't you divide it by 5 now?
Now we're ready to start doing our inverse operations. So we divide both sides by 5. What do we get? 8 equals x. If you want to write it as x equals 8, either one of those is fine with me.
Wait.
All right, what was our first step on number 8?
Combine like terms.
Combine like terms. We have 32 equals
16.
16a. Then we need to do it on both sides. What do we get for a? 2 equals a. You could write a equals 2. Same thing. If you like seeing the problem split up, feel free to put your line in there.
Don't you gotta cross off this one like with an A and one?
You can.
Cross that out. Alright.
Yep.
Okay, that
You can
works.
cross those out if they cancel. Let's talk about number 9. We already said our first step is to distribute. What are we distributing? The -4 gets distributed into the parentheses. This is why we had a whole lesson about distributing, because we need to be able to do it for this. When we distribute, what do we get? So then this is the tricky part. The 4 is negative
It's a positive.
and the 6 is negative. So as Jasha said, a negative times a negative is a positive. 4 times 6 is
24.
24. Gotta watch your signs. Is there anything else that we can simplify? No. So now we're ready to do our inverse operations. Trying to get n alone. So yes, we subtract 24 on both sides. What does that leave us with?
It's only -12.
Negative 4.
Good. -4n equals -12. Last step. How did we get n equals 3?
You gotta divide 4 from 12.
Not just a 4, but a -4. And then we get n equals +3. Yes, I do expect to see all this work. Everything that I showed, I expect you to show. The only exception would be things like the box around the n and the squiggly lines. All that other work I should be seeing from you. All right, on number 10, what's the first thing I should do? Distribute what?
8.
Distribute that 8. When I distribute 8, what do I get? 8w plus 8. What else is still there? -3 equals 48. Now what am I able to do? Good. We need to combine like terms. So that means that we can combine the +8 with the -3. If they are on the same side of the problem, we can combine them. only if they're already on the same side. So when we combine them, that gives us 8W.
I thought it'd be subtracting. Yeah, I thought it'd be 8.
Plus
Okay.
So plus 5 here. Still equals 48. Do we have questions about that step, combining like terms? Is there anything else we can do to simplify? I hope we're saying no very quietly to ourselves. So now we're ready to do our inverse operations. What happens first? Subtract 5 on both sides. That leaves me with 8W equals 43. And then my last step is to divide by 8. Does that divide nicely? No, it's not going to divide nicely. I am totally fine with you leaving it as 43/8. Leave your answer as an improper fraction. That is okay with me. Liam? If you got a decimal answer, what did it come out to be?
5.375.
Okay, if you were to do that, you would have to give me the whole decimal, like you said out loud. You cannot round it or shorten it. But if you give me the whole decimal, that's okay. Sometimes the whole decimal isn't an option. Like it repeats or it keeps going off the screen of your calculator. Okay, in that case, I wouldn't even try it because a lot of people don't write them correctly. I would just start getting cozy with improper fractions. What can we do when we start off number 11? Combine like terms. What gets combined? Good. Our R terms get combined. That gives me what? 15R. Everything else is staying the same right now. So the minus 7 equals 8 just stays where it was. Good. So now we're ready to do things to both sides of our equation. So the first thing we would do is add 7 to both sides. 15R equals 15. Now what? Divide both sides by 15. And what do we get for R? R equals 1. Questions about number 11? All right, on number 12, what's the first thing we can do? Distribute. What's getting distributed? The 8. When we distribute, what do we get?
48.
Plus?
8R.
8R. Make sure you're distributing to both terms. Still equals 40. Now this one's a little different from some of the ones we've done. What do you think we need to do?
Subtract 48.
Good. Subtract 48. We're still trying to get rid of addition, subtraction stuff first. The 48's getting added. So in order to get rid of it, we subtract it. We want it to zero out. That's the whole idea. All right, what are we left with? 8R equals negative 8. Last step. Divide both sides by 8. What do we get for R? R equals a negative 1. Very good. Make sure you have that negative sign. If you don't, it is wrong.